Hello everybody and welcome to today's tutorial. I'm going to pass this tutorial with you. My name is Parisa and I'm so glad that I have you all here. Uh, Let me share my screen and start the meeting. So I wish you have all watched video 1 so that we can discuss about it. Does anyone have any question about the video? So, as you have mentioned in this tutorial, we're talking about multiple linear regression and polynomial regression. First of all, I'm going to run these small parts so that we won't have any problem running the rest of the codes here. And I think as no one has had any question about the video, we've heard so much about the mathematics, and so I'm not going to make you tired by reading these lines. And first of all, we just discuss a bit about multiple linear regression, and then go to coding parts. Then we will return, and if there was any other problem with these lines, we would discuss that again. So first of all, the one thing that was not covered in the video, I think, was that why do we learn this? Why do we need to learn an equation like this and apply it in a computer, apply it as a code? So I'm going to give you a very simplified example. As you know, we are learning all of these things to get more familiar with neuroscience and its uses. And imagine that a baby wants to learn something, and we want to analyze learning process. So I start from a baby. Baby wants to distinguish this lemon from any other object in the room, any other thing that it sees. So what makes the baby understand it? The lemon has a number of features, a number of inputs that comes to the baby's minds about this lemon. And for example, a neuron is responsible for that. Distinguishing, so I'm going to add it here. If we consider the output of a neuron is going to tell us if it is a lemon or not, it's going to sum up a number of features. So the output can be reliable on the color of the lemon, its shape, and also, for example, taste and smell, and a number of other factors. But we've just seen a lemon here, but there are so many other objects that we might see, and we have to distinguish them. For example, I have a glass here, and all of these inputs go to that neuron. So how do we distinguish them? Each of these inputs and features have their own weight. So it can be specified in this way. Specified in this way. Weight 1, weight 2, etc. And if it is a lemon, the weights are 1. If it's not, or if some of them are not related to lemon, then the weights are lower. For example, look at this tomato. The shape is similar to lemon, so the coefficient of shape becomes 1. The weight is 1. But the color is not. So the color can be similar to yellow. It's less than 1. Could be any number, and also other factors. So here we need an equation like this, as you have seen. However, it's not so much, it's not like this example. It was just an example to understand it much better. Here, So we just have this equation, theta 0 plus theta 1 times x1 plus theta 2 times x2 plus etc. And there is also a background noise here that is added as epsilon. And thetas, as we discussed, is responsible for the weights. Thetas are responsible for the weights, and x's are the inputs. And we just convert them into vectors so that we can write it down like this.